Lesson 1.4 is building functions from functions. Basically, looking at what we can do with functions. We'll start with how do we add, subtract, multiply, and divide functions. And then one of the big things we're going to look at is compositions of functions. And just, everything that we can do with functions. So, as we start up at the top here, some few basic rules there for combination of functions. And this is just basically saying, if you're asked to find f plus g of x, realize that that is the same as saying, okay, what is f of x plus g of x? Okay, don't get thrown off by the fancy notation or anything, just let that be. But f plus g is asking you to do f of x plus g of x. In the same manner, f minus g of x is asking you to do f of x minus g of x. Same thing with multiplication and division. You see f g of x, separate f of x times g of x, and f over g of x, f of x divided by g of x. So very basic pieces there, but just realizing that yes, I don't know, those rules are legal, I guess, so to speak. So over here in example 1, we're going to look at some basic examples. Now, if I recall correctly, some of the homework ones get tricky, so you'll have to work with those, but we'll talk about them. But let's start with f plus g. If I'm asked to find f plus g of x, thoughts? What is f? X squared? What is g? Square root of x plus 1. So f is x squared. G is square root of x plus 1. What is x squared plus square root of x plus 1? That, right? What he said? Okay. X squared plus square root of x plus 1. Okay. So what does that say about f minus g of x? Same thing with the subtraction sign. In other words, f is x squared. This is minus. We're going to say minus. G is the square root of x plus 1. When I go to clean it up and simplify, what is x squared minus the square root of x plus 1? X squared minus the square root of x plus 1. Okay? Obviously, if there's like terms, should you add them?
Yes.
Yes, okay. Will you see some like terms in homework at times?
Okay.
Yes. Okay. Will there always be like terms? No. Okay, so just beware. I think I'm going to put FG over here. So if we're doing FG of x, that means we're going to take f and multiply by g. So what is f? X squared. What is g? Square root of x plus 1. You made me second guess myself. Okay. And what is x squared times the square root of x plus 1?
That.
It is that. Okay. Now, in homework, if there's something you can multiply, will you want to multiply it? Yes. Okay. And again, it depends on the situation. I should have looked. I don't remember exactly what homework examples are, but I just do remember there being some that you have to work a little harder at. It might mean you have to FOIL or distribute to multiply them together. Okay. We've got one more. F over G. X squared over square root of x plus 1. What is x squared divided by square root of x plus 1? Okay. And I am going to say you get to leave it like this. Now, what could be the glitch there?
The square root.
Yeah, technically, are we supposed to leave square roots in the denominator? Technically, no. But here's what I'm going to tell you. There are times in upper level math they don't throw a fit about it. Okay? So, if they don't throw a fit about it, we'll enjoy it. Okay, so just realize when they ask you to do these 4 operations, put them together. If they're simplifying, you can do it, right? Okay, so this is more one that I want to focus on. This is one that's always a little bit more of a struggle. Composition of functions. Now, that's the fancy formal word. So when we talk about composition of functions, first of all, it uses that little dot. I don't want to say dot. That makes me think multiplication dot. That little open circle. And that's called a composition circle. And this says f composed with g of x. Except, we did this last year in Algebra 2, didn't we? I don't usually read it as f composed with g of x.
Say fog.
I say fog. Okay. Now, I don't know if other teachers do that or not, but you've heard fog? Okay, so I'm not totally, I don't know what you ladies are thinking, but.
I don't remember.
I'm thinking, why do we have to do it again? It was worse the first time.
Well, okay, and here's the deal, guys. Fog, as we say, so composition of functions, this develops as we go more in math. Okay, if you're hanging with me for calculus, you have to be able to compose functions. Okay, because we definitely go into, we don't necessarily call it fog, but we do lots of work with functions. Okay, so, f composed with g of x, also written as f of g of x. So we keep it in that order, and the idea is you take the entire function g of x, and you plug it into f of x. So let's practice here. You'll always be provided f and g, yes?
Yes.
They'll be in the problem, they'll be in the directions. You don't get to make up your own, and you don't always use these right here. Okay. Now, in this particular problem, f is e to the x, g of x is the square root of x. So let's start with f composed with g of x. Okay? As I think about f composed with g of x, or what I affectionately refer to as fog, okay, realize to rewrite that, I can think of this as f of g of x. And I like that visual because that visual shows me that g is going into f. Okay? So that's why I like that visual. And so, debating how I want to think about this. So if g is going into f, what is g? G is the square root of x, yes? So if I take kind of a middle step, and you may not want the middle step, but if I take a middle step, and I go ahead and just say, okay, g of x is square root of x. What I'm actually going to be doing for f of g of x is I'm going to do f of square root of x. Because I'm taking whatever g of x is, which is square root of x, and I'm going to put it into f. So, when I say f of square root of x, I'm going to take my f function. Every place I see an x, I'm going to replace it with square root of x. Okay? So, f of g of x, I'm going to take g, put it into f. What is g? Square root of x. I'm going to put it into f. Where do I put it into f? Any place there's an x. So if f is e to the x, I'm not going to leave a question mark there, but if it's e to the x, what are we putting in place of x? Square root of x. So this is going to be e to the square root of x. Okay, any place, so g goes into f. That means whatever g is goes into f. Any place I see a variable, an x, within f, it becomes whatever g was. Okay, and then of course there's always the, can I do anything to clean this up? Not on this one. On some of them will you be able to? Definitely. So f composed with g of x is e to the square root of x. Now, what happens when I reverse my function composition? Instead of fog, We talk golf.
We talk golf.
Okay. So G composed with F of X. If it's G composed with F, I don't know if you like this visual or not, but that means it's G of F of X. So essentially, what are we doing? We're going to take F and put it into G. F goes into G. And you can go straight to that step. You don't have to write any more steps. F into G. Have you thought about it? You think you know your answer? Think about it. Try and say a step ahead of me. F into G. So F into G. Okay. Now, if I think about like I did last time, it's G of what is F? E to the X. So that's kind of a, you know, if you want to put that step in or not, you don't have to. But that's saying that F is E to the X. It's going to go into G. So every place I see an X in G, it gets replaced with E to the X. So it was square root of X, right? I'm not going to put that in X, though. What am I going to replace X with? It's going to be E to the X there. So square root of E to the X. And realize we definitely got two different answers there, didn't we?
Yes.
Okay. So there is a difference between whether you do F of G of X or G of F of X. There is definitely a difference. Okay. Questions? You're going to get a little more practice in this next piece. Okay. The next piece is actually talking about domain, but as we talk about domain, we have to find the composition first. So we'll get to practice a little bit there. Okay. So, finding the domain. To find the domain, you must first find the composition. Okay, they provide us F and G. Notice my F and G are different, aren't they? Okay, so you have to pay attention to what F and G are. It wants the domain of F composed with G and G composed with F. Well, to talk domain, we have to see what that composition looks like. So, ready to practice again? F composed with G of X, which I try and keep the habit of then rewriting that it's F of G of X. G is going into F. So G, what's G? Square root of X is going into F. And F is what? X squared minus 1. So here's a way to think about it. F is something squared minus 1, yes? That's what F is. What are we plugging into it? G, which is the square root of X. So what's going to go right here? It's going to be the square root of X. And then we're going to square that. Okay, so, and this is where we have to think. Okay, so this is what fog is. F composed with G of X. And yes, I agree with Kylie. It is really just X minus 1. However, I'm getting ready to talk about domain. And so because we're getting ready to talk about domain, I'm actually going to leave it like this. Because did they actually ask me to find the function composition as an answer? No, they're asking me to find the domain. So I'm going to leave it. I'm not going to actually do the simplifying, but I'm not disagreeing with your comment. Okay? There's just a catch here I have to watch out for. So when we talk about domain, Domain are the what type of values? X values, right? So they're what type of values can we put in here? And this is why I left it as is because of this. Can I put any old value in here? Okay. So if I leave it written like this and we realize that x that Kylie wants to say of x minus 1, I can put anything in for x, right? But can I put anything I want in for square root of x? No, because to put a number under square root, it has to be positive. And so that's why, basically, when you think about this function composition, you need to think about, okay, what was f? Well, f, I can put anything I want into f. G, can I put anything I want into g? No. And so because I couldn't put anything I want into g, I can't necessarily put anything I want into the composition. And so you know that these values have to be positive, right? I wrote x greater than or equal to 0, but we've been doing interval notation. So what is that in interval notation?
0.
0 to infinity. Can we use 0?
Yes.
Yes, you can take the square root of 0. Okay, square root of 0 is 0. Okay, so that's what you have to watch out for is when we do these function compositions, think about where did the composition come from. Go back, check what f is, check what g is, and thus the reason I didn't simplify to x minus 1. Okay, where am I at on time? I shouldn't have said anything, huh?
No, I was real focused.
That's good. That's good. I like focus. Let's at least go ahead and get the composition done. We'll probably talk about domain tomorrow because, domain's a little bit more deep topic, isn't it? Okay, it's a deeper, more difficult topic. So we'll talk about that tomorrow. But okay, g composed with f of x means I'm going to do g of f of x. Thoughts? Can you visualize what it's going to be? I think maybe he said it, I'm not sure. I couldn't fully hear the answer. If f is going into g, what is g? Square root of x. What am I putting in place of x? X squared minus 1. Okay? And that one we can't simplify anymore. Do not ever try and say, oh, hey, square root of x squared minus 1 is x minus 1. Big old false. Not just because I don't want to simplify here, I can't simplify it. If you're going to take the square root, you can take the square root of pieces multiplied together, but you cannot take the square root of pieces added or subtracted. That's a big no-no. Okay? So, yeah. Tomorrow, remind me, this is where I need to pick up. We'll talk domain here. Because, as I said, that's a little bit more difficult topic that homework will not be due tomorrow, if that's what you're asking. No. I do want to talk, because I want to talk about that. Decomposing. You actually should have a little bit of work time tomorrow, I think. Okay? So come prepared for that. And that means homework will be due, what, Thursday?